Okay, so for today, we're going to talk about Rioxarray. Okay, so last lecture we talked about Xarray. It's a package for doing like handling multi-dimensional label data set. Okay, I still want you to remember Xarray is very popular in the climatology community, and also it can be used to read all kind of raster data set, especially in NextCDF. But in Geospatial, for raster data set, we usually handle GeoTIFF, okay, or cloud optimized GeoTIFF. So Rioxarray is a combination of raster IO and Xarray. Okay, so this is what I call Rioxarray, raster IO. So if you remember, we use raster IO to read the data, and then you can use NumPy array, you can do the plotting. Xarray to use to read NextCDF, but it also has all the label, all the stuff. So raster IO is a perfect case combining these two. So it makes it easy for you to manipulate the data with label. So you can do bang. You don't need to remember the indexing, like what's the absolute index. We can use it much easier, right? So if you remember for the raster IO, I asked you to clip the imagery. You need to figure out the CRAs and the transform and then do all the stuff. It's like very challenging. Raster IO makes it a lot more easier. So we're gonna go through the example how to use that and how to open the data and then basically read it as a NumPy array and then you Xarray, and then you can have access to all the Xarray functionality. So Xarray is very, very powerful. If you really learn it very well, you can easily get a job somewhere doing any geospatial. So nowadays, local company, also cloud computing, they use Xarray to handle raster dataset. And so of course you need to import the install the Rioxarray and raster IO. So we have covered it in the lecture about installing the geospatial and then import the library. So you can just import Rioxarray, or you can, some people you'll be we're doing like this, import Rioxarray as RXR. You also see this one, kind of the convention. So it's up to you. For this notebook, I just use the original one. But you can, if you see RXR, usually represent Rioxarray. Okay, and once you import it, then we can start opening the dataset. So if you remember for the Xarray, how do we open a dataset using Xarray? What function does it use? XR dot what? Open dataset. Remember? So this one here is similar, but it says open raster IO. So you can think about here, it's using the raster IO as the backend to read the data and then return the result as an Xarray, not as a NumPy array. Okay, so it's a little bit different. So what we're doing here, I'm going to go online to read this same data set. So this is the same data set that we use for the raster IO lecture. Okay, but right now we're using that for the Rioxarray data set. And so look at this. So right now the return result is an Xarray.data array. But for the raster IO, look at this one. Reading the data set. Look at this. They are very much similar, except that for the raster IO to open, it's going to return just a reader pointing to the file. You don't really get the data. If you want to get the data, you need to use the .read function to get the data, right? So where is it? Custom accessing, right? You need to use the .read. Where? Right? .read. You need to read each band. So for this one, you don't have to. You just Rioxarray.open raster IO. So basically, use raster IO to open the dataset, do some transformation, return the result as Xarray.data array. And once you have this, look at these coordinates, right? Bang, we have 1, 2, 3, 4, 5, 7. You have X. X is basically just the coordinate. You have index. You have attribute. So there are a lot of attributes. So this is the same data set that we use for the raster IO lecture. And then you can look at the dimension. Again, the dimension, I want you to remember the dimension basically means think about X, Y, Z, right? or XYZ time. So those are the dimensions. Basically, how many dimensions do you have? So for this one, we have band, right? And then we have X and Y. So basically, X is latitude. Oh, no. X is longitude, okay? Y is latitude. The band is how many bands? So if you go to this X-ray lecture, look at this one, right? So right now, think about this is the cube. Right now, we're doing a landscape imagery, right? So you'll be, this will be Y, for example, X, and this one, for example, this will be the band, right? So basically, it's a data cube. Look at like one imagery, one band is just two-dimensional. If you have multiple bands, then you stack together, then it become a data cube. So X, Y, band, right? And you can also X, Y, band, and then you might have a time dimension, or the band can be time, can be anything. So there might be 3-dimensional, 4-dimensional. There's so many ways. So remote sensing data, think about here. I have one landscape imagery covering Knoxville, right? You'll be X, Y, band, like one imagery. And then will be, the next image will be X, Y, band, right? But you can put them all together as a 4-dimensional data set. So it depends on how you want to organize. But the data will be looking like this. It's just a so-called data cube. And you have the coordinates. The coordinate basically is the similar to the dimension, except that the coordinate is the real coordinates, right? So for every dimension, right, you have latitude, you're going to have all the value for the latitude, all the value for the longitude, and also the band, how many bands you have. So basically, this usually corresponds to the dimension. The dimensions give you the label. The coordinate give you the real value for every dimension. Make sense? So for example, for band will be blue band, green band, red band, near infrared band, short wave, blah, blah, something like that. And then the X will be how many latitude, right? 23.5, 23, 24, 25, something like that. So this is the coordinates. The coordinates is where you pinpoint the point in the data cube. Make sense? Okay, so coordinate dimension. Sometimes you get very confused. And then the attribute is easier. Attribute, this one is like there are a lot of attributes in here. So basically it's just a dictionary. And these are very much similar using the same X-ray. The next section is really Rioxarray is about. You will see this one here. .io, this is called assessor. ACCESSOR, assessor. Basically, you have this variable, and because it's open using Rioxarray, right now it has this RIO assessor. So RIO assessor means you are getting access to the information associated with raster IO. Because we open the data set using raster IO, so if you remember, raster IO has this .cis, right? src.cis, src.metadata, src.something. So you can actually, all the information is available through here. So again, I'm going to go back to here. Right now, this is a combination of the two. And I want you to understand where does those come from. It's similar to this one, right? src.something, src.metadata, src.cis, resolution. So it's from this data assessor. Because right now, this data, this variable here, is an X-ray data array. But under the hood, there's .io. Right now, it doesn't show you the auto-completed list. But everything that you can use with raster IO is should be available from here. For example, CIS. Right? So you can see the coordinate information. You can should be able to see the, oh, it doesn't have the resolution. Anyway, do we have the metadata? Oh, no. Okay. That's bad. So it's not everything. Maybe the profile. What? Really? I saw it's available. Anyway, so just the CIS, that means the coordinate information, and also the transform. So these two pieces of information are very important, because without that, you will not be able to overlay on the map, right? Because this one gives you the real world locations. Because X-ray, you have all these coordinates, but still at the end of the day, you need to have a projection to be able to match the real world coordinates. So if something is missing in here, you can use this function .io.writeCIS. That means if a data set is missing the coordinate information, just like when if you remember, right? I saw you some example in the previous lecture. When you project a data set into QGIS, it's showing in the middle of the ocean. That means it's missing the coordinate information. Then you can use this one, .io.write CIS, to assign a projection into that. But make sure that you are assigning a projection that you're supposed to have. But if you're doing a reprojection, it's a different issue. Sometimes if the imagery, they have this projection, but it was missing, the file is not complete, you can assign it. But you cannot just assign it randomly using any projection. It's still going to be wrong because it's not going to match with the real world, real locations of the data set. Yes? Or in place equal true means that you want to replace this data. Basically, it's something similar like this. So actually, I don't need this one. In place is similar to, I think, when we use pandas or geopandas. Sometimes you also use this one. In place means that you don't, it's modifying the data and then override it. So in that way, you don't need to assign to something else. So basically, it's override itself. So what this one is doing here is this data available, because if you don't have the, let me show you what this one, right? So let me show you here, data.rio.cis. Look at this one. So right now, this is the projection, right? So without using this one, take a look. This here, RCS, so I can change it to something else. Let's say 38, 57. Oops. So run it. And so right now, you see, I'm just changing the writing a CIS into this file. And let's look at whether the previous one has changed or not. So we can run this one again. You see, it doesn't change. But if you already want to like override it, I can just in place equal to true. Then you probably later we will change. So in place equal to true. This is dangerous, but let me copy this one because I might forget what projection it is. So right now, if I write in place, and we come back to see this one, it's changed. So this is something like if you're running a series of actions, if you don't want to like something equal to something all the time. So some of the function we have this in place equal to true. That means you can change it and you will replace it. So basically, you're doing something, modify yourself, and then you want to replace yourself. So that means you keep the variable name the same, so you don't have to rename the variable all the time. But like I said, don't write the CIS like just give a random name, you're going to have trouble. So I need to replace it again. So now I come back to the original one. It's still this original projection. Make sense? So in place is basically modifying yourself. Yes? Use some raster IO stuff. So basically, you can think about, we use the Rioxarray to open the raster IO. So behind the scene is using raster IO to open that data set. So raster IO, because once it's open, you can have access to some of the attribute. But it's converting the NumPy array stuff into Xarray. But you still have those metadata information in there. So that's why you have the RIO accessor. But if you're just opening using the Xarray, you will not have this one. Okay, are we clear now? So it should be simple. Are we slow enough? Okay, so next one, you see here the reprojection. So look at this. If you remember previously, talk about the raster IO reprojection. Oh man, this is crazy. See how many lines of code. I know if I give you the quiz asking you to do this without any help from the internet, you probably struggle a lot because this is not easy. You need to deal with the profile, you need to deal with the projection, you need to update the metadata, you need to, there's so many things you need to take care. But compared to this one, look at this. Data, right? So original projection is this one, UTM 32611. I don't remember exactly what it is, but you can just Google it. EPSG. UTM zone 11N, right? So this is just UTM projection. So you can convert to WGS4 so that you can have latitude and longitude. And just one line, data.io.reproject, and you can reproject to 4326. So 4326 is not a projection, it's just a coordinate system, latitude and longitude. And it's going to take some time, but do you prefer this one or the one on the raster IO doing low level yourself? This one, right? One line of code. So you don't have to thinking like how to open the data set, how to deal with the profile, and reduce the line from, I don't know how many lines, probably 15, 20 lines. I hate this one. So when I was learning it, I really don't like handle all this low level. I would like just one line of code. Just give me, because my goal is to convert it to something that's easier to use. So this is converting to EPSG 4326, just WGS 84. So there your data set, we have latitude, longitude, rather than X and Y. X and Y is just like the unit is meters. This one is easier. Okay. And you can save, I will show you how to save the data set later. So next one, clipping a raster. See how easy it is? Just provide a bounding box and then the same data assessor. So this one is basically reprojecting. So right now, this one is latitude, longitude, and that's why you can provide this latitude, longitude bounding box. Otherwise, it'll be meter, the number will be pretty big, but this one is pretty small. And then just write IO.clip box, clip bounding box, and then provide this one, and then it's done, right? It's not going to take long, only like 0 seconds. But again, look at the clipping raster using the bounding box. Which one? Oh my goodness. This is tough, right? Now it's not so difficult. So if you ever need to clip a raster or something, you can open the data set, just one line of code, open using a Rioxarray, and then just do the clipping. Yes? Good question. So it all depends on the projection. So what you need to do is just look at, for example, right now, this is the reprojected data we want to use. Is just .io.gis. So you will see this one is 4326. This one is WGS 84, so it's latitude, longitude. But if there's something else, for example, is data.this, you will see this number in here. So if you are not something that you, let me see here. So yeah, I remember the metadata is not available, but let me show you. So I guess it should be somewhere. I don't remember because okay. Worst case, I'm gonna say SRC equal to raster IO. Let me import raster IO so I can show you the differences. Raster IO, and then I can say SRC equal to raster IO.open. Okay, and then the URL. Right. So now I can src.metadata. No, bounce. Okay. So look at this one, right? So this is the original data set using UTM. So you can see the bounding boxes. These are basically the number. So your number will be within these bounding boxes. But if you're using, if you already converted, then let me see if it has the bounce attribute. Oh yeah. Cool. So maybe it bounce, right? So actually you have this one. It's the same thing from here. But right now, because we already did the projection, converted to WGS 84, so the data reprojected, so bounce, you will see the coordinates looks like this. So that's why your bounding boxes need to be within the bounding boxes. This one is the outside bounding boxes. So you get an idea what value you need to provide. And the reason that we do the conversion into WGS 84 because this number is easier to understand, right? If I give you a number like this, probably having a hard time. What does that really mean? Right, so when you're doing the clipping, you might want to like convert it to WGS 84. Okay, and so the next one, you can even use a what's they called? Use a vector data set to do the clipping. So for this one, we're going to use a vector data set, and then we're going to read it, and we're going to convert this one to clip this data set using these bounding boxes. And so the same idea is that you need to make sure they're in the same projection. So the data.io, right? So this is the original one. You see here? So this is the last number. So my polygon is also UTM projection. So they're the same one, and that's why we can do the clipping easily. And then you can see now it's much smaller. So this is the original shape. Or it's kind of a little bit different. What I'm saying is you should be doing this one, data.shape. Right, so this is the original one. This is after we do the clipping. So it's still 7 bands. How many rows? 522 rows and 514 columns. So this is how we can do the clipping, and very much similar to, again, in the previous example, using raster.io is using something like this. And you always need to deal with the metadata update to make sure you deal with the CIS transform. And that one is so annoying. Is unless you really know what it's doing, sometimes it's like, why we have to spend so much time trying to save a data set, trying to clip one. And there's a better way. So Rioxarray is a lot easier to use. So if you ever need to deal with raster data set, I would recommend using this one. So you can do using either raster.io, it can access to raster.io information, but you can also utilize Xarray, and it's a lot more easier, more like higher level, so that you don't have to deal with the low level stuff. And a couple more examples, you can work with resampling. So we can do the reprojection, and you can change the spatial resolution. So the original spatial resolution of the dataset is 90 meters. So with this one, again, we're using an IO assessor, and then we project. So what kind of projection you want to use? If you don't, you can use the original one. So this will be the original projection. And then you can specify the resolution, 1000 by 1000 meter. The original one was 90 by 90. So you'll be much smaller. And then if you want it, you see, now it's much smaller, right? So compared to the original one, is this big. Resample means you can change it from high resolution to coarse resolution, because sometimes if the data set is too big, like 1 gigabyte, your computer doesn't have enough memory, then you might need to like reduce the resolution, and so it makes it much faster to process, because you end up with much smaller number of pixels. So that's about resampling. You can also extract a small subset, but the previous one here, we already talked about the clipping, but that one is using real coordinates, and then you need to pass in a vector file. But you can also do clipping using Xarray. So this one is using the Xarray. So if you remember this one here, this one we don't use the IO assessor anymore. We use because this one is Xarray data array. So the data array has to talk SEL, if you remember, right? And this is where you can pass in the X, Y, the slice, right? So the slice, the latitude and also the longitude, right? X is the longitude, Y is the latitude. So you can also doing clipping using this way if you want to. So there are two ways. Basically, you can either use raster.io to do the slicing, or you can use Xarray to do the slicing. So in general, Xarray is much easier because you can specify this label. So this is called why it's called multi-dimensional label dataset, because we have the dimension, right? X dimension, Y dimension, also the band dimension. So this one can give you, for example, right now you have subset the dataset, so it's a much smaller one. So let me ask you. So this is the Landsat data with 7 bands. How do I extract, for example, the first 3 bands? Also do the clipping here, the clipping. So again, right, we have the X label, we have the Y label. So what's the other label that it has? Right. So this is the data array. It has X, it's Y, and it has band. So you can also do a subset of the band. So you don't have to use all of them. If it's, you can just do it here. Band equal to, you can do 1 if you just give just the first one. You see, it becomes just a 2-dimensional. But you should be able to do, for example, let me see if we can provide a list. Yeah, you should be able to. You see, so this is a subsetting 3 bands. So I just want to get the first 3 bands. You can also reorder them. You don't have to be like 1, 1 to 3. I can say 3, 2, 1. You can reorganize the band if you want to. So this is kind of like in desktop GIS. You open a raster data set and then it has too many bands. You just want to extract the 3 bands. In Xarray, it's so easier, right? You can just select based on the bounding boxes how many bands you want, and then just a couple lines of code, and you can do all kind of manipulation. So it's a lot more flexible for doing data manipulation using Xarray. So that's about some basic stuff. And the next couple examples just doing visualization. So similar to raster.io and Xarray, this one is actually using Xarray. So again, very much similar. So you can create a figure, and then you can select what band do you want. Then just calling this Xarray. So remember, right? .sel is to select the data array, and then .proc.imshow. Everything, basically, you can use everything that we covered in the previous lecture in terms of like visualization, Xarray. You can just use the plot function. You can also customize it, right? The different color map, and you can also stack them all together. So there's so many different ways you can do the plotting in using Xarray. Under the hood is using matplotlib, so it's the same idea. So again, we create the plot, how big you want the plot to be. And right now, this is the data array, right? Coming from the projection, the WGS 84. And then you select, okay, I want B band 432. That's it. And then just doing the plot, I am so, and then you can give like a minimum, maximum. If you don't provide this one, probably the image sometimes will be a little bit dark because by default it's from 0 to 1. So if you need to have a higher contrast, you want to lower the maximum so that anything above that is going to be basically stretch the range so they become brighter. And that's why if you want to access this one, so for 0.3, it looks pretty bright. So if I change it to 0.1, what will happen? What do you expect to see? Is it become darker or brighter? Brighter, right? Because the layer log value is greater than 0.1. So anything greater than 0.1 will be close to the right side. So it's going to be a lot of bright spots. And that's just too much. That means a lot of values are greater than 0.1. So it's too much. If you say maybe 0.5, yeah, it's okay, but it's still a little bit dark. So I think 0.3 is a good number. So you can see this is Las Vegas. So you can see the water, you can see all the stuff. And this is pretty simple, right? Title, X label, Y label, and then PLT show. And look at how nice, right? So right, this is why we have this latitude and longitude, right? Because it's easier to understand. But you can certainly use the same one. I'm going to show you the other way. Instead of using the projecting one, can we use the original one? The data, the original data array without projection. So that one is UTM, right? 32611. You can render it as well, but just the number, right? This is what you're talking or asking about. How do you know the unit? How do you know the number? The original number, this is actually not latitude and longitude. It's like X and Y. So probably need to change this one, X, Y, and then run it. Right. So this is the last number. This is the original UTM projection. The unit of UTM projection is meter. So that's why the number pretty big. So it's from on the lower left corner, the origin. And so when you create the map, this is hard to understand. This one is a little bit easier because you have latitude, longitude. People understand it's from negative 180 to positive 180, something like that. And you can do the subset. For example, you can, this one here, this is the subset data set, right? So select. So everything pretty much similar. So the overall workflow will be like this. You open the data using Rioxarray. You can do some manipulation, reprojection, clipping, select the bands, whatever. Once you are done, you end up with another data array, right? And that data array, you can just use the .plot, .plot.imshow, and then just add the label, add the X, Y. So it'll be simple. So next time you give a question, like later I give you a quiz, open this data set. I give you the data set, open using Rioxarray, plot it. In your mind, it should be like, open the data set, If you need to manipulate, otherwise dot plot. It's three lines of code. So it's not that complicated. So this one here, we're just doing the subsetting and then plot it. You see? Pretty nice. So how do you do it? This one in Desktop.js? You need to open it, and then you need to maybe draw, we have a polygon or something like that. You need to create a shape file or something like that. This, you just give the coordinates, and then you can get it done pretty easily. If you want to read it to be more advanced, you can add a color bar here. And one thing I want you to see is this one. What I do want you to notice in here, if you don't have this one, it's going to end up with like very long the name, because the color bar, the legend, is based on this long name. So the long name, I mean the original one is pretty bad because I already changed it. So now you cannot see the original one. So yeah, I already updated it. So sometimes if you get the label, the title for this color bar is something look very weird, then you update the data attribute. So data.attribute, and then update the long name, because Xarray automatically use the information from the attribute to plot. So if you don't change it, it's going to look like this. Because I already changed it, so I cannot go back. I forgot what it is. Like, it's a very weird stuff. Maybe, let me do it one more time. I just want to show you. You will run into this one because it also, I was like very confused. So, okay, so right now this is what it is, right? I read it one more time, and let's look at the long name. If you scroll all the way down, it looks like this. Okay, so right now, if I go back to the example here, I don't change it. And let me comment out this one so you will understand the differences. Is it going to work? I hope so. Because right now it's going online to read the data again, so it's pretty take some time. Look at this, right? So this is what it looks like if you don't change the long name, because it's using automatically from the metadata. So that's why this line, I use this one to update it. So this can be anything that you like, and you can also change the color, the color map. So I can change it to anything that you like, and you see. So you can plot some vector data on top of the raster. You can update anything. So everything you see on the plot here is customizable. So you can do whatever you want. So by now, you should be able to handle any raster data set. If I give you a geotiff, what should you do, right? Open it, manipulate it, plot it. And the last step will be to save the result. So this is saving data here. Data.io.toRaster. And that's it. Simple. You automatically use all the CIS because this data assessor has all the information in the .io and .transform. So in that way, you don't have to handle it yourself. And like I said, if you go to the raster.io and writing the data set, it's not so convenient. You need to deal with the profile, and you need to deal with the CIS and also the band and every stuff. It's challenging for beginners, but Rioxarray is easier. It's just .io.toRaster, okay, and that's it. And I have a couple more examples here. We don't have time. Let me just quickly go through it, just to show you the output. You can do the projection, convert to different projection, and then you can plot them. So that's why I want you to see the differences. Right, so if you use the WGS84, you want to have latitude and longitude. If you don't use that, you use other projection, you end up with number like this. Okay, so negative 1 point something, and then 1E7, basically 10 million. Okay, 1 to the power of 10 to the 10 to the power of 7. So it will be 10 million multiplied by this number. So it's a big number. So if this is not what you want, then you do the reprojection to WGS84, EPSG 4326. Then when you plot it, it will look like this. Okay. Then you can specify the coordinate, latitude, longitude. This one is actually XY, is not latitude, longitude. And lastly, you can do the same thing. You can create calculate the NDVI, normalized difference vegetation index. Similar to what we did for the raster.io, right? If you remember correctly, it's the same thing, but right now we're using Xarray to do it. And after that, you can just create a plot. You can do some masking. You can extract the result. Very much similar to what we did for this one. Create. Where's the NDVI one? Yeah, kind of similar to here. But this one is using the raster IO to do that. Using NumPy array, right? You have the equation, you can do all this stuff. This one is using Xarray. So in here, the equation looks very much similar. But the difference is right now using .SEL to select the data array. Compared to the raster IO one, is using .read. If you remember here, use src.read. So this one is using NumPy array. The other one is using Xarray. So Xarray is easier because you talk SEL, and then you can do the clipping, you can do the slicing, so you have a lot more functionalities. So try it out. This should be a pretty straightforward. You can see it gets a little bit easier compared to just using raster IO itself to handle all the low-level stuff. And so in the future, if you need to deal with raster, come to this page, or look at the source code, open the dataset, manipulate, and then save it, and then plot it. That's all you need. All right, so that's all for today, and I will see you in the next one.